Imagine the moon blinks out of existence tonight. No warning, no cosmic explosion, simply an instant, complete disappearance. Standard pop science answers usually focus on the immediate biological inconveniences, darker nights for nocturnal predators, or confused migrating birds. These ecological disruptions, however, overlook a massive planetary-scale mechanical failure happening right beneath our feet. This collapse would be governed by a single physical quantity: angular momentum. Earth and the Moon operate as a tightly coupled mechanical system, locked together by gravity in the vacuum of space. Within this system, the Moon functions as a massive 73 quintillion-ton gyroscopic stabilizer for our planet. Losing it forces an immediate disruption of Earth's foundational physical parameters. To understand how our planet relies on this distant mass, we have to look at the geometry of Earth itself. Our planet is often drawn as a perfect uniform sphere. In reality, Earth is an oblate spheroid. Because the planet is spinning, centrifugal force constantly pushes its mass outward, away from the poles. This creates a distinct equatorial bulge, making the planet roughly 26 miles wider across its equator than it is from pole to pole. This extra ring of mass acts as a physical handle that gravity from other celestial bodies can grab onto. If Earth were a perfect sphere, its axial tilt would be immune to outside gravitational forces. Because of this bulge, our rotation is vulnerable to the rest of the solar system. We can trace the impact of this vulnerability back 4.5 billion years to the formation of the Earth-Moon system. After the initial collision that created the Moon, Earth was spinning at an extreme rate, resulting in a single day that lasted only 6 hours. This diagram shows how the newly formed Moon applied gravitational pull to Earth's oceans, creating a distinct tidal bulge. Because Earth rotated faster than the Moon's orbit, ocean floor friction dragged this bulge slightly ahead of the Moon's position. This physical misalignment initiates a process called tidal dissipation. The Moon's gravity pulls backward on this leading, offset mass of water, applying a constant counter-rotational force to Earth. This continuous friction acts as a global brake pad, gradually slowing Earth's rotation and lengthening our 6-hour day to 24 hours over billions of years. The law of conservation of angular momentum dictates that this rotational energy cannot simply disappear. The energy Earth loses from its rotation is transferred directly into the Moon's orbital energy, physically pushing the satellite further away from us. Our current 24-hour day is a temporary snapshot of a billion-year transfer of momentum. While rotational speed determines the length of our day, the far more critical parameter for life is Earth's 23.5-degree axial tilt, known as its obliquity. This precise angle dictates the distribution of sunlight across the hemispheres, providing predictable seasons and stable climate zones. This stability is constantly under threat from the gravitational pull of the Sun and Jupiter. Jupiter possesses an immense gravitational field that heavily influences the mechanics of the entire inner solar system. Both the Sun and Jupiter tug continuously on Earth's thick equatorial bulge, attempting to flatten our tilt. This constant pulling creates the risk of orbital resonance. Resonance occurs when the rhythmic gravitational tugs from these external bodies perfectly align with Earth's natural rotational wobble, amplifying that wobble destructively. If Earth were left alone with only the Sun and Jupiter, this amplified resonance would eventually cause the planet to tumble uncontrollably through space. The single reason we do not tumble is the Moon. Look at this wireframe of Earth's axis. The gravitational forces from the distant Sun and Jupiter are constantly trying to pull the equator out of alignment, but the Moon's massive gravitational torque instantly overpowers them. This lunar torque forces Earth's axis to wobble, or precess, at a much faster, tighter rate. This accelerated wobble completely breaks the synchronization required for a dangerous orbital resonance with Jupiter. The mechanics are identical to a rapidly spinning toy gyroscope, resisting the pull of Earth's gravity by wobbling tightly around its central axis. The Moon serves as a mechanical anchor, locking Earth's tilt firmly at 23.5 degrees and actively preventing a total climate collapse. We return to time zero. The Moon vanishes tonight, and the mechanical link is severed. The heavy braking torque applied to Earth's ocean bulge ceases. The sun's gravity still generates minor tides in the oceans. However, the sun is too far away to create enough friction to significantly slow Earth's rotation any further. The gradual lengthening of our days permanently stops. Losing the moon freezes Earth's rotational clock at exactly 24 hours, abruptly ending billions of years of mechanical evolution. Fast forward hundreds of thousands of years into the future of this moonless Earth. Without the lunar anchor forcing a rapid precession, the Jovian and solar perturbations begin to take control of our equatorial bulge. This graph maps axial obliquity over time. Without the moon, Earth inevitably falls back into a destructive orbital resonance with the solar system. Pushed to extreme mathematical limits, Earth's tilt would swing chaotically from 0 degrees all the way to 85 degrees. At an 85-degree tilt, continents would face months of boiling, direct vertical sunlight, followed immediately by months of total freezing darkness. Our habitable, temperate climate relies on this fragile mechanical equilibrium. The moon acts as a vital, active component of Earth's physical machinery. Every time humanity looked up at or walked upon the lunar surface, we were standing on the very engine of our own survival. How many other potentially habitable exoplanets in the galaxy are tumbling through space right now, completely sterile, simply because they lack a massive lunar anchor? The moon operates as the invisible hand of physics, mathematically permitting life on Earth to flourish.